Today we are going to learn about creating and distributing Python packages. We will explore how to package Python modules for distribution, focusing on skills like creating, testing, and publishing Python packages.
Welcome to our session on creating and distributing Python packages. In today's digital world, sharing and deploying your code efficiently is crucial. Packaging your Python code allows you to share it with the community or deploy it in production environments, ensuring your code is scalable and reusable. Let's dive into the essentials of packaging Python modules. To create a Python package, it's essential to understand its structure. A typical package is a directory containing a special _init_.py file and one or more Python modules. The _init_.py file can be empty, but its presence indicates to Python that the directory should be treated as a package. Organizing your modules into sub-packages can help manage complexity, especially in larger projects. Additionally, including files like readme.md and setup.py provides valuable metadata and configurations for your package. Setuptools is a powerful tool for managing Python packages. It simplifies the process of configuring your package through setup files. Start by ensuring Setuptools is installed using pip. The setup.py file is where you define your package metadata, including name, version, author, and description. Specify package details like modules, packages, and dependencies to ensure everything is bundled correctly. For command line tools, you can define entry points in the setup file, allowing users to execute scripts directly from the terminal.
The setup.py file is the heart of your packaging process. It acts as a script for installing your package. A basic setup.py includes essential information and uses the setuptools.setup function. Here's a simple template. Start with import setuptools, then call setuptools.setup with parameters like name, version, and packages. List dependencies using install_requires. If your package includes non-code files, specify them with package_data. For advanced users, custom installation commands can be added using the class argument. Managing dependencies is crucial for ensuring your package runs smoothly. Use the install_requires parameter in setup.py to list required libraries. Specify versions carefully to avoid conflicts. Consider optional dependencies for features that aren't essential. Testing your package with different dependency versions can help catch issues early. Using tools like pip's requirements.txt in conjunction with setup.py can streamline dependency management and ensure users have the necessary libraries installed. Testing is a vital part of package development. Python's built-in unitis framework provides a robust way to validate your code. Start by creating test cases that cover various parts of your package. Each test is a method in a class that inherits from unitis.testCase. Use assertions to check for expected outcomes. Running tests is simple with the command python m unitis discover. Test-driven development, TDD, involves writing tests before code, ensuring your package meets specifications and reducing bugs. Versioning is key to managing your package's lifecycle. Semantic versioning is a popular system that uses a three-part version number, major, minor, and patch. Increment the major version for breaking changes, the minor version for backward-compatible additions, and the patch version for backward-compatible bug fixes. Follow best practices by updating version numbers with each release and clearly documenting changes in a changelog or release notes. This helps users understand updates and maintain compatibility. Publishing your package to PyPy makes it available to a global audience. Start by registering an account on PyPy. Next, prepare your package for distribution using Setuptools to generate a source distribution and a wheel. Twine is a tool used to upload these files to PyPy securely. Use the command twine upload dist/ to upload all your distribution files. After uploading, your package is live and can be installed using pip. Manage future releases by incrementing version numbers and updating package files.
Once your package is published, ongoing maintenance is crucial. Monitor user feedback to identify bugs and areas for improvement. Regularly update your package to introduce new features and address issues. Strive to maintain backward compatibility, ensuring users' existing applications aren't broken by updates. Enhanced documentation improves user experience and adoption. Engaging with the community through forums or GitHub can provide valuable insights and foster a loyal user base. We've covered the essential steps of creating and distributing Python packages, from understanding package structures to publishing on PyPy. Packaging your code is a powerful way to share your work and contribute to the Python community. Remember to follow best practices, stay updated with the latest tools, and engage with users. As you start packaging your own modules, consider exploring additional resources to deepen your understanding. Thank you for joining us on this journey into Python packaging. Happy coding!